Hi, everyone. Today in chapter 2, we're going to be moving on to talk about hydrocarbons. Ooh, having some trouble there. Okay, so hydrocarbons, as their name suggests, are compounds that contain only carbon and hydrogen. And they are classified according to the source of where they come from. So there are hydrocarbons called aliphatic, which are usually from fats and oils, and they mostly contain carbon-carbon single bonds. And aromatic hydrocarbons, which we usually see in things like essential oils, and they contain both single and double bonds. Now we're going to focus on first chains of the first variety, single bonded carbon hydrogen chains. Now, to classify a hydrocarbon based on the type of bonds it has, we use these following phrases. Alkanes, with the ending that I've highlighted, ANES, anes, means it contains only single bonds, carbon-carbon single bonds, and carbon-hydrogen bonds. Alkenes contain at least one double bond. And alkynes, with the YNES, contain at least one carbon triple bond. There's another variety of structure also called arenes, which contain a ring of alternating carbon single and carbon double bonds. An example of this is benzene. So again, mostly I want to focus on the ending here. This is very important, the ane, ene, and eine ending. So ane is single bond only, ene is at least one double bond, and eine is at least one triple bond. So we have some examples here. This first example, this is all in line bond structure. I'm going to continue showing structures in this format so you become more and more familiar and comfortable with the format of line bond. So here, remember, each point is a carbon, and those are attached to hydrogens, which are not shown. So these are all hydrocarbon structures. The first structure is all single bonds. So it would have an ane ending. This structure here, the second structure, has a double bond. So it would have an ene ending. This structure here has a triple bond. So it would have an eine ending. Now this structure here is a ring, but notice it does not have alternating single and double bonds. It still just has single bonds. So this still would just have an ane ending. We're going to get into rings later in section 2.3, but this is still just single bonds, and we're just talking about what kind of bonds it has, so it would have an ane ending. Now, to name alkanes when they're linear, not in a ring, but just linear, the IUPAC, or official naming rules for organic compounds, shows that we name according to the number of carbons that are there. And the prefix is going to be as shown, where the number of carbons shows the prefix. So for one carbon, we use meth, 2 eth, 3 prop, 4 bute, 5 pent, etc. These generally are using a system in which, if you're familiar with any Latin-based languages, at the numbers there, for example, from 5 up, pent, hex, hept, oct. I think the only ones that are different from any type of Latin-based language are the initial ones, meth, eth, prop, and but. So this is just something that you're going to have to memorize, which is the number of carbons and the name associated with that number. Now, I want you to at least do 10, up to 10, but you should kind of have an idea of maybe what higher numbers would look like. For example, in this undec, dodec, into 20. But the ones from 1 to 10 are going to be the ones you're going to see the most often, especially 1 through 4, meth, eth, prop, but. Remember these, they are quite common and they are a little bit odd in their naming scheme as opposed to the numbers after that. And you can see that the end part of the name has to do with if it is single, double, or triple bonded. So all of these in this table here are single bonded. That's why they say unbranched alkanes. Alkanes, ane meaning single bonded. So methane is a carbon with single bonds. Ethane is 2 carbons with single bonds, and so on. Okay, so let's try naming some structures using the table right now and our line bonds. So here, remember we're going to count points for carbons. This has 1, 2, 3, 4 carbons. So it is butane. 1, 2, 3, 4, 5, 6, 7 carbons is heptane. Now, I drew this one a little bit odd. This is not how you would normally draw a structure, but I want you to remember it's all about where the points are. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons is nonane. So that's how you name simple, just linear hydrocarbons that are single bonded. So again, we use the term alkane for that.